Control charts for attributes. This is chapter 8. In this chapter, we are going to understand key concepts associated with the control charts for attribute. We are going to understand how to use them and how to build them. And we are going to review a quality rating system. So let's start refreshing our memories about the attribute definition. The term attribute refers to those quality characteristics that conform to specifications or do not conform to specifications. So the attribute term is used where measurements are not possible. For example, let's say that you are supposed to do a visual inspection of a house in terms of the painting job. Okay, so in this type of inspection, you can visually inspect items such as the color, if it's missing parts or different part of the wall, or if it has scratches, or if it is damaged. Also, the attribute concept is used where measurements can be made but are not made because of time, cost, or need. For example, if you're trying to inspect a lot of, let's say, glass bottles. Those that are going to be used later on in, let's say, Coke products. Although you can measure the diameter of the hole, it is more convenient to use a passed or failed or go or no-go gauge, right? And determine if it conforms or does not conform to specifications. Where an attribute does not conform to specification is when we're going to be using various descriptive terms such as nonconformity, defect, defective, or nonconforming unit. So let's start with a nonconformity. A nonconformity is a departure of a quality characteristic. And a quality characteristic is coming from your customers, right? So it's a departure. That product doesn't have the quality characteristic anymore. And it could have a severity. And that severity sufficient could cause an associated product or service not to meet a specification requirement. So once again, it's a departure of a quality characteristic. And that means a departure of satisfying your customers' specifications. Now, a defect is concerned with satisfying intended normal usage requirement. It is a characteristic of the product that does not meet the customer's requirement. For instance, you can have, let's go back to that painting job. You can have a missing area of that wall that is just, let's say, missing some paint. You have a defect there, but doesn't mean that you cannot use the house for its intended purpose, which is living in the house as a shell. Okay? So once again, the defect is a characteristic of a product that does not meet the customer requirement. It doesn't mean that it doesn't work. It's just missing that specific characteristic, quality characteristic. Now, a defect is appropriate for use when evaluation in terms of usage. And a defective is appropriate for use when a unit of product or service is evaluated in terms of usage rather than conformance to a specification. When we have a defective, now we have a situation where you cannot use that specific product or service for its intended use. In the case of a painting job for a house, you might have caused a damage that you have, let's say, produced a crack in the wall, and it might be now a high severity, so you have a high problem that you might not be able to use the how for its intended use. So that's the difference between defect and defective. You can have different defects in a specific product, but still the product is meeting its intended use, functionality. Now, if a unit is defective, it means that it does not work. To give you some example, you have defective, and you can have a defective rope. It means you cannot use it, because if you use it, it will break, and it will not meet its intended use. You can have defective apples. It means you cannot eat it. They're not good. Now, as a defect, this is a USB, and if you see it that way, you said, well, it looks like it's a good product. But this one, in fact, has two defects. One is that there is no built-in clip. So if you want to attach it to your belt or shirt, if you're just walking or running, you can. You have to hold it. So that's what was one of the defects. And the other one is that the USB cap is already becoming loose. Is it still doing what it's supposed to do, which is to play music and serve as a storage of music, but has some defects. A computer. You look at the computer and say, well, it looks good to me. Well, this one, in fact, has a misplacement of the USB ports, the battery, and the pricing. So that is the difference between defective and defects. Now, nonconformity is appropriate for conformance to a specification. And the term nonconforming unit is used to describe a unit of product or service containing at least one nonconformity. So think about this: nonconformity and defect, and nonconforming unit and defective. Now, it is important that you understand these definitions, because if we go back to the chart that we used when we went over control chart for variables, we're going to be using the same one to understand when to use the control chart for attributes. If you have a defective, means a non-conforming unit, and you have constant sample size, you can use a P char or NP char. If you have a sample size that is not constant, you need to use the P char with variable sample size. Now, if you have defect or nonconformities and your sample size is constant, you use the C char. If your sample size is not constant, you use the U char. So this is how you do the selection. So let's start reviewing the different type of attribute charts. The nonconforming units are based on the binomial distribution. And what are the characteristics of the binomial distribution? Well, these different charts have an infinite number of items. Also, this type of distribution provides two possible outcomes, and they're constant. And the trials are independent. So these are the characteristic of the binomial distribution. And the type of charts that we use here are the P chart and the NP chart. How about the nonconformities? Well, the nonconformities are based on the Poisson distribution. And some of the quality characteristics of the Poisson distribution is that it is applicable to many situations that involve observations per unit of time or per unit of amount. And there are many equals and independent opportunities for the occurrence of an event. And these type of charts are the C chart and the U chart. So let's start with the P chart. The P chart is used for data that consists of the proportion of the number of occurrence of an event to the total number of recurrency. This type of chart is used in quality to report the fraction or percent nonconformity in a product, quality characteristic, or group of quality characteristics. The formula used is P equal to NP divided by N, where NP is the number nonconforming in the sample or subgroup, and N is the number in the sample or subgroup. The fraction nonconforming P is usually small, say 0.10 or less. And because the fraction nonconforming is very small, the subgroup size must be quite large to produce a meaningful chart. This value greater than 0.10 will indicate that the organization is in serious difficulty and that measures more drastic than a control chart are required. So that's why that number needs to be small, very small. And because the fraction of conformity is very small, the subgroup sizes must be quite large to produce a meaningful chart. The P-chart is an extremely versatile control chart, and it can be used to control one quality characteristic, like we do when we do the X-bar in our chart, to control a group of quality characteristics of the same type or the same part, or to control the entire product. So the good thing about the P-chart is that it can be established to measure the quality produced by a work center, a department, by a shift, or by the entire plant. So what are the objectives of the P-chart? Well, the objective of the P-chart is to determine the average quality, and this is very important because it is used as a benchmark. And this information provides the process capability in terms of attributes. Also bring to the attention of management any changes in the average, either if it's increasing or decreasing, and this is very significant for management. Improve the product quality. And this is good because it provides a continuous effort to improve quality. So it's like a continuous improvement. Evaluate the quality characteristic, the quality performance of the operating and management personnel. Also, suggest places to use the X-bar and R chart. And this is good because those are type of charts that are easier to use. And determine the acceptance criteria of a product before shipment to the customer. So how do we build one? So let's start understanding how do we build one for a constant subgroup size. This follows the same methodology that we described when we went over the control charts for variables. You first have to select the quality characteristic. Okay, this could be a single quality characteristic, a group of quality characteristic, a part, entire product, or a number of products. Then you determine the subgroup size and method. And you need to remember that the subgroup size here is a function of the proportion nonconforming. For instance, if you have a part that has a proportion nonconforming P equal to 0.001 and the subgroup size N is 1,000, then the average number nonconforming NP will be 1 per subgroup. Okay? The minimum size suggested is 50. Then you have to collect the data. And to collect data, you need to remember that you need for each subgroup, the proportion nonconforming is calculated by the formula P equal to NP divided by N. Then you calculate the trial's central line and the control limits. The central line is P bar equal to the sum of the NPs divided by the sum of N's. You find the control limits, the upper control limit and the lower control limit. And if the lower control limit is a negative value, you will change it to 0. You plot your data. And if you notice that you have a out of control process, you have to, or out of control chart, you have to remove those subgroups, those points, and then you establish revised central line and control limits. So you have to recalculate it. And that is your formula. The P bar new will be equal to P sub O or 0. And you will have to subtract the values that you're taking out of the chart. And you calculate your control limits as well and see if you have achieved your objective. This P chart is more effective if it is posted where operating and quality personnel can view it, because they're easy to understand. Also, you have to remember that the control limits are usually 3 standard deviations from the central value, and this means that approximately 99% of the plotted points P will fall between the upper and lower control limits. If you have variable subgroup size, so that means that your upper control limit and your lower control limit is not going to be a straight line. It's going to have up and downs because it's not constant. You do the same procedures. You calculate, you collect the data, you select your quality characteristic, you collect your data, and you determine the central line and the control limits. Now you have to do it for each subgroup size because they have different sizes. Okay? It's just a little bit of work, but it's the same procedure. You need to understand or remember that as the subgroup size gets larger, the control limits are closer together. And if you plot the data and you see that you have an out of control chart, then you have to revise the central line and the upper and lower control limits. So if you P sub 0 sub O which is the standard reference value of the proportion nonconforming, is known, the process of data collection and trial control limit is not necessary because you can use that value and substitute it in the formula. Okay. You also need to remember that P is the proportion nonconforming in a single group, and it is posted to the chart but is not used to calculate the control limits. The P bar is the average proportion nonconforming of many subgroups, and it is the sum of the number nonconforming divided by the sum of the number inspected, and this one is used to calculate the trial control limits. The phi is the population proportion nonconforming. And when this value is known, it can be used to calculate the limits, since the P sub 0 sub P sub O, which is once again the standard reference value of the proportion nonconforming, is equal to phi. Now, if you have variable subgroup size, there's a way that you can minimize this effect. Okay? And the problem is when the control limits vary from subgroup to subgroup, it presents an unattractive chart, and it is difficult to explain to the operating personnel. So there are 2 techniques that you can use to minimize the effect of the variable subgroup sizes. One is the control limit for an average subgroup size, okay, and the other one is the control limit for different subgroup sizes. For the first one, the control limit for an average subgroup size, this is by using an average subgroup size, one limit can be calculated and placed on the control chart. So the average group size can be based on the anticipated production for the month or for the previous month inspection. So here you need to calculate the n average, which is the sum of the n's divided by the g, which is the subgroup size. And then you calculate the control limits. Now, when an average subgroup size is used, there are 4 situations that occur between the control limit and the individual fraction non-conforming value. And the first one is case number 1. And this case occurs when a point falls inside the limits and its subgroup size is smaller than the average subgroup size. In this case, control limits are not needed. Case number 2, this case occurs when a point falls inside the average limit and its subgroup size is larger than the average subgroup size. At this point, it seems that the point is beyond the individual control limit, so we have an out of control situation in this case. Case number 3. This case occurs when a point falls outside the limits and its subgroup size is larger than the average subgroup size. And in this case, control limits are not needed, as well as case number 1. In case number 4, this case occurs when a point falls outside limits and its subgroup size is less than the average subgroup size. And it seems that the point is on the individual control limit, so it is assumed to be in control. So you can have this for different situations. Now, it is not always necessary to calculate the individual control limits in cases, once again, 2, 1, and 4. Only when the value of p is close to the control limit, it is necessary to determine the individual limits. Also, it is not necessary to calculate individual control limit as long as the subgroup size does not deviate substantially from the average. Let's say 15%. And if you have average subgroup size used, the individual control limits are determined infrequently. Let's say it about every 3 months. Okay, the second case is the control limits for different subgroup sizes. And this one is used to establish control limits for different subgroup sizes. What you have to do is to calculate the n average and the upper and the lower control limit. This type of charts can be effective when there are extreme variations in subgroup size. Okay, so now that you understand more about the P chart, let's understand more about the NP chart, which is the number nonconforming chart. And it's almost the same as the P chart. However, you would not use both for the same objective, okay? The NP chart is easier for operating personnel to understand than the P chart. Also, you can do the inspections results. You can post it directly to the chart without any calculation. And if the subgroup size is allowed to vary, the central line and control limits will vary, which presents a chart that is almost meaningless. So one of the limitations of the NP chart is that require that the subgroup size must be constant. So you do the same. You need to calculate the central line, which is n times p sub o or sub 0, and you need to calculate the control limits. The p sub of p sub 0 is the fraction nonconforming, and if this one is unknown, you have to determine by collecting data and then calculating the trial control limits and obtaining the best estimated of the p sub 0. The trial control limits formulas are obtained by substituting the p bar for p sub 0 in the formulas. So how can we calculate the process capability? Remember from prior lectures, the only way that we can calculate the process capability is knowing that the process is in a state of control. And we can do the same here when we do control chart for attributes. Now it's much simpler than when you are calculating the process capability of a variable, and that was part of chapter 5. Okay, in fact, the process capability for attribute is the central line of the control chart. Very simple. And it is management responsibility, calculating the capability of a process in terms of the attributes. Now, when the plotted points or point is outside of the control limit, is the operating personnel responsible. It was usually responsible for it. Okay, so we went over control chart for nonconformity. How about the count of nonconformity? And the nonconformities chart controls the count of nonconformity within the product or service. And an item is classified as nonconforming unit whether it has one or many nonconformities. And remember, nonconformity is associated with the defect definition. So the count of nonconformity is what we know as a C chart, and the count of nonconformities per unit is what we call the U chart. So these charts, once again, are based on the Poisson distribution. So there are two conditions that must be met. One is that the average count of nonconformities must be much less than the total possible count of nonconformities, and that the occurrences are independent. The objective of this type of chart is that they determine the average quality level, and this is information give the initial process capability. Also bring to the attention of management any change in the average, and improve the product quality. And this is to give more ideas for improvement. Evaluates the quality performance of the operating and management personnel. And since the charts for count of nonconformity are usually applicable to errors, they are very effective in evaluating the quality of the functional areas of finance, sales, customer service, and so on. They suggest places to use the X-bar and R chart, and there are some application of the chart for the count of nonconformity, and this lend themselves to more detailed analysis by the X-bar and the R chart. And determine acceptance criteria of a product before shipping to the customer. This is very important, and these objectives are almost identical to those for the nonconforming charts. So you have to make sure that you're cautioned to be sure which one to use, or which one is appropriate to use, okay? So the construction of the C chart is identical to the other charts. So you select the quality characteristic, then you determine the subgroup size and the method, and then you collect the data. Once you have the data, then you calculate the trial central line and the control limits, and then you have the different formulas. And when the lower control limit is negative, you need to change it to 0. Plot your chart, and if you have some out of control state, you will have to recalculate the central line and control limits by removing those points that are out of control. And make sure that you achieve the objective. And the reason for the control chart is to achieve one or more of the previously stated objective. The C chart is applicable where the subgroup size is an inspected unit of 1. Okay? Now, when situations arise where the subgroup size varies, then you have to use the U chart, which is the count of nonconforming units. And you follow the same procedures. You calculate that count of nonconformity unit in a group. Then you calculate the average count, which is the sum of all of them, and you calculate the upper control limit and the lower control limit. You plot the data. If you see that you have some out of control points, you remove them and you revise the lines. And this is how you revise it and calculate the different upper control limit and lower control limit. Okay, so with the use of the count of nonconforming unit, the U chart, you need to remember that the scale selected is continuous for the U chart. That means that it can have decimal places. Now, for the Z chart, it's discrete. The subgroup size for the U chart can vary, and for the C chart is equal to 1. And the U chart is limited in that we don't know the location of the nonconformity. The last part of this chapter is the understanding what a quality rating system is. Okay, and in the attribute charts, all nonconformities and nonconforming units have the same weight regardless of their seriousness. Okay, so what a quality rating system gives you is just a way that you can correct this deficiency. Now, there are many situations in which it is better to compare the performance of operators, shift plans, or vendors. And in order to compare quality performance, a quality system is needed to classify, weight, and evaluate nonconformities. Okay, so nonconformities and nonconforming units can be classified according to their severity. And one system groups nonconformity into 3 classes: critical nonconformities, major nonconformities, and minor nonconformity. The critical nonconformities are the unsafe conditions for individuals using, maintaining, or depending upon the product. Major nonconformities, they can result in failure or reduce materially the usability of the product for its intended purpose. And minor nonconformity are the ones that can reduce materially the usability of the product for its intended purpose. So a critical nonconformity will affect usability. A major nonconformity might affect usability, and a minor nonconformity will not affect usability of the unit. Other classification system used 4 classes or 2 classes, and this is dependent of the complexity of the product. If you want to use a 4th class, you can add a catastrophe class, and this is usually used. So once the classification is determined, now you need to find out the weights. You need to assign weights to each class. And then you can start using the rating system. So in this lecture, we cover the control chart for attributes, understanding when to use nonconformities or account for nonconforming units, and also we have reviewed a quality rating system.